Okay, let's talk about wind energy. It's certainly an exciting topic, something that's going to apparently become more and more predominant source of energy in our lifetimes. So let's just learn a little bit about it. The good news is it's pretty straightforward, at least in terms of the physics of what it does. Okay, so basically, wind energy, we're just going to directly convert the kinetic energy of moving air, wind, uh, we're just going to use that flowing fluid to turn a turbine and turn a generator and make electricity. So it's the same process that we do using steam in, say, a coal plant or a nuclear plant or a hydrothermal plant. But in this case, we're just letting the wind do it for us. Now, because the wind isn't under the kind of pressures that we have in these other systems, the answer is have a much larger blade in order to generate the torques that you need to get this thing to move. So basically, you just have these very long blades, and these blades can be you know, uh, like 30 meters long, and they'd be quite large, maybe even bigger. And basically, the wind blows, it turns this, it turns the generator, and out comes power. Now, how much energy does it produce? Sorry, I have problems here. Um, they vary in size. Okay, so over the last few years, they've gotten bigger and bigger. Currently they're around here. They're producing about, and this gives you a sense of scale. So here's Statue of Liberty. I mean, this is kind of Americentric, but you sort of see like there's a rather large structure there. So this is a 100 meters here. So we see these things reach up to almost 150 meters in height, and they generate about 2 megawatts of power. When they're operating at their most efficient, and they cost about $2 million each to build. So 2 megawatts is not a whole lot. So you need a lot of them to generate the kind of electricity you need, and each one costs $2 million. But as much as that seems like it's expensive, if you compare that to building a coal station might produce 300 times as much electricity, but it costs $2 billion. So actually, it costs more money to build a coal power plant, than it does for the energy you're going to get. You're paying more for the coal plant than you are for the wind. All right, so basically, 300 wind turbines equals one typical coal power plant. You do the math, you see it's actually cheaper. So, and it's also got the added benefit that the thing about the wind is it's renewable, right? So it's always, the wind's always going to blow as long as there are temperature differences on the surface of the earth, which there always will be. As long as there's a sun, the wind is going to blow. So that is a big win right there. Okay, so it is free, permanent energy. Can't run out. If there's no carbon emissions, there's no CO2, there's no hazardous waste associated with it, except maybe a little bit in the manufacturing of it. But even then, that's not that much. And it's something that can be scaled to meet the societal needs. Like if we wanted to, we could go 100% wind. Now, it would take a lot to do that because they don't produce that much. As far as the energy density per area of surface, they're not that high of density energy providers. So you need a lot of them scattered all over the place, but it can be done. And the other thing is you can operate them in countries that don't have a large established grid. So you can have electrical power in places where right now it's just not really feasible to build a coal plant or a nuclear plant. So here's what's wrong. Let's just talk about the problems associated with it, because we definitely need to think about this before we take the leap and make this our only way of generating electricity. So the biggest problem is this: the wind doesn't blow constantly, right? Sometimes it's very windy, sometimes it's not windy at all. If you see these now, okay? I mean, like as you drive around the countryside, you'll see them, and a lot of times they're not even moving, okay? And so the one of the problems we're faced with is when the wind is blowing, that's great. We have power, but when it's not blowing, we don't. And right now, we don't have any mechanism for storing large amounts of electricity on a power grid. We just can't do it. We don't have these massive batteries that we can charge up when the wind is blowing so that we'll then have energy when it's not. So it doesn't work like that. So for that reason, we'll probably never be able to go all wind. We'll need some other source of energy that is not dependent on wind conditions. So what they do is they're working on what we call a smart grid system, and a smart grid system just basically means that we have real time communication between the various components, so that I can have like a standard like coal or nuclear fired power plant that's going to generate constant electricity, but the amount it has to generate varies. So when the wind is blowing really well, we can back off on how much of this we're producing. And then when the wind stops blowing, or we can also hook it up to solar, and the sun's gets cloudy, whatever. If we're producing less of this type of renewable energy, we just produce more of this conventional energy. And smart grids can be a lot more complicated than that. We'll talk about that. But the bottom line is, it works, but it only works if we sort of reinvent how we distribute electricity to account for these variabilities in the power output. And I don't care what Texas said; their power outage was not about the wind farms. Okay, here's a problem you'll hear a lot about, and they'll probably put this on the test. This is an environmental class, and so this is something they'll probably talk about, and that's the fact that wind turbines do kill a lot of birds and bats. There's no getting around that. They definitely kill them. And here's why. If you think about this, okay, these things, they're not like propellers on an airplane. You've seen them probably. They turn pretty slowly. They might only go around 5, at the most 20 times a second, which that'd be really fast for one of these things. So why would that kill birds? Well, because if you look at how fast this part of the blade is moving, if it's going to go in a circle close to the hub, well, that's not very fast. But when you get out here, this could be 80 meters from here to here, and so this thing is going really fast, like 160 kilometers an hour. And so birds flying in this region here can't get out of the way fast enough. So it definitely kills a lot of them. So, for instance, in the United States, right now, we get about 7% of our electricity from these things, from these windmills. And as a consequence, we have like 500,000 birds, like 500,000 birds die each year. And that's not even taking account bats. Now, that sounds terrible, and it is. But consider this. Birds run into buildings and cars all the time, and millions and millions die that way every year. But nobody's saying let's not have cars or buildings. And cats kill billions of birds a year. And I don't hear anyone saying we need to outlaw cats. All right. So the point is, this should not be a deal breaker for people. All right. And not only that, it's something that we can work our way around. There's things we can do to reduce this. Okay. So for instance, and on the APES test, they often ask you to come up with solutions. Let's think about this. One solution is don't put them in migratory corridors. So have ecologists map out where birds tend to fly during their migrations, and don't put your wind farms there. Another thing you can do is for bats is bats use echolocation, so you can blast these super loud ultrasonic sounds, and the bats kind of like, I don't like this area. They move away. This has been shown to work. Another one that's kind of weird is you can paint the blades different colors. So it turns out that insects get drawn towards the blades because they're bright and reflective, and how bugs tend to like light. Okay. At night. All right. So if you make them dark, then the bugs aren't attractive. The bugs aren't attractive, then the bats aren't attracted. It's as simple as paint your turbine some other color, and you eliminate a lot of the problem. Another thing is you can shut down the turbines when the wind is blowing very slowly. So if you're not generating much electricity anyway, well, might as well shut them down, because it turns out bats, bats are more endangered than birds, and they do get killed quite a bit. Bats tend not to fly when it's super, super windy. And so when the wind is low, you're not making much electricity anyway. So why kill bats when you're not making much electricity? That's one thing. And then you have certain high value birds, like ones that are endangered, like eagles or condors. And so one thing you can do with those is you can simply track them, or you can actually have radar, so you can kind of tell when they're coming. Anyway, so there's things we can do to reduce this. This should not be a deal breaker. Now, another thing to keep in mind too is, and I didn't put this in my presentation, and I should have, is that the wind doesn't blow the same everywhere, right? There are places where it blows more than other places. And so a lot of times on ridge lines of mountains, or there's certain wind corridors through certain valleys. So it makes sense to congregate your wind farms there, where you're more likely to get consistent, strong winds. But one problem with this is that's often places that people enjoy views. And so these things are kind of ugly, and they're kind of noisy if you're near them. So people they basically take away from that cultural ecosystem service, right? So we like to look out at nature, but now we got these things there, and it kind of look at this picture. I mean, it just doesn't look great. Okay. And so what do you do about this? So one is you could try to get people to feel like a sense of pride that we're switching away from coal. This is something we could do to save the planet. There's that. Okay. Another thing you can just do is this. You know what? Why don't we just put them someplace where we're not going to confront them much, offshore? So one solution is just put them in places where maybe like offshore, or put them on farmers' fields where there's a lot of wind anyway, and the farmer can make the profit from harvesting their crops, but they're also getting money from renting out the space uh, for electrical generation. Because basically, when you have wide open places, there's less friction, so the wind can blow better. And the best place to do that is offshore, because offshore there's absolutely nothing holding the wind back, and you have that added benefit. Remember, we talked before about the sea breeze and the land breeze. So if you've ever been to the beach, you notice the wind blows a lot there. And that's because there's big temperature differences between the ocean and the land, and so that's what makes wind. Is these temperature differences make these convection currents. So it's an ideal place. It's like a win-win. The only problem is it's more expensive to build them offshore, but that's the way the world is going now, because you get better wind. People don't complain as much because it's offshore a bit. It's generally out of the corridor of most migratory birds. There's no bats out there, so it really makes a lot of sense to do it that way. And that seems to be the current trend, is to go that way. So they like I said, the disadvantage of this is they're way more expensive to build and maintain when you put them out there. But the wind does blow more consistently, and you get like 3 times more energy produced by each one of these devices when you put them out there. And basically no one owns it. The government tends to own it, so it's a good deal. And in fact, here in Korea, the government has a Green New Deal of its own, and they just put in a huge amount of money, like 44, the equivalent of 44 billion US dollars, which is a huge amount of money, and they're going to build the world's largest wind farm. And they're basically, what they do is they mapped it out to be off the west coast, and basically they sample the winds and just see, like, okay, look, this is kind of interesting. How many watts per square meter of wind energy can you get here, right? And so what we see is there's certain regions where you have a higher amount of power available per square meter of surface area. And so that's probably where they're going to locate this. But it should be operational by the year 2030. It should produce about a little over 8 gigawatts, which is a lot of energy. I think it's going to be about, I think I heard like maybe, I think eventually it could get big enough to where it could provide 10% of Korea's electricity. But right now, if you can, right now Korea needs about 127 gigawatts, so it's not quite there yet. Anyway, that's wind energy. Thanks for listening.